Now we are going to start with the P block, and in the P block first we are going to start with the 15th group. As you all know that P block elements are those in which the last electron enters the P block, right. So we have actually the group ranging from the 13 to the 18 which are included in the P block. So we are going to start with the first group, that is the 15th group. So the 15th group is particularly a nitrogen family, and the elements which we have in it is nitrogen, phosphorus, arsenic, antimony and bismuth. And as far as their symbols are concerned, you all are familiar with that nitrogen is N, phosphorus is P, arsenic is As, antimony is Sb and bismuth is Bi, right. And you know that if we occur they are actually quite reactive, so how they occur in nature. So actually if we talk about the abundance first, so nitrogen is the 33rd element which is found in the earth crust, and likewise the phosphorus is found at the 11th position out of all elements which are found in the crust. And you know that how nitrogen occur in earth crust, it occurs in the form of niter generally, that is KNO3, or it occurs in a form of soda niter which is NaNO3. This is the general form in which the nitrogen occurrence is there in the earth crust, that is in the nitrate form. So it is particularly niter, that is KNO3, or soda niter which is NaNO3. And you know the phosphorus, it occurs in the form of ore, that is phosphorite. It occurs in the form of ore, that is phosphorite, which is Ca3PO4 whole twice, that is calcium phosphate if we talk about their chemical name. And as far as their abundance are concerned, that is arsenic, bismuth and antimony, they occur rare in earth crust, but still they are serving as important use. They are used in electroplating, they are used in making alloys, so there are a lot of uses that we will discuss later. So starting with this group, that as you all are familiar with the members now, so we will start with the first property, that is the basic property, that is the electronic configuration. So the first property is electronic configuration, as it is a 15 group. So the general electronic configuration is Ns2Np3, that is 2 electrons in the S subshell and 3 electrons in the P subshell. So we will just write the configuration, and you also try to write in your copies, as you all are familiar that how to write the electronic configuration. So atomic number for nitrogen is 7, it is helium 2, 2s2, 2p3. 3, 4, 5, 6, 7, that means total is now 7. Likewise, we will write for phosphorus, it is 15 atomic number, so neon 10, 3s2, 3p3. Arsenic is 33, so argon 18, 3d10, 4s2, 4p3. Antimony is 51, so krypton 36, 4d10, 5s2, 5p3. And in bismuth it is 83, so xenon 54 followed by 5d10, 6s2, 6p3. So this is how you are going to write the electronic configuration. So what similarity do you observe? Because they are member of the same group, so that means their general electronic configuration is Ns2Np3. As you can see here, all of them has 2 electron in the S, outer S, and 3 electrons in the outer P subshell. Right. So this is how you are going to write the electronic configuration. So as they are member of same group, that is why you found the similarity in their configuration. So now starting with the other property, that we will talk about their atomic radii and the ionic radii. So what we have seen actually that this is 14 group actually, and 15 group, and the group which is present before it is 14. So we are going to compare its size with 14 also, and as well as along the group members also. So what we have seen here, if we compare the size from 14 and 15, we see that they are actually smaller. They are actually smaller. The reason being, because as we know that as we move in a period, because they have electronic configuration something corresponding to Ns2, Np2, and here the configuration is Ns2, Np3. So that means electron is being added here, right. So when electron is being added here, so we see that nuclear charge actually increase. With increase in the electron in the same shell, nuclear charge increase, and due to which the size decrease. So if we compare the size of 14 and 15, obviously 15 is going to be smaller. The reason being because due to increase in the electron in the same shell, which result in a increase in the nuclear charge and decrease in the size. But if we talk about the group members of 15, so we see that as we move down, size increases. In general, we know that whenever we move in a group, size increases, because as you can see here, it has 2 subshell, last shell is 2, here the last shell is 3, here the 4, here is 4, 5 and 6. So that means as you are moving down, so every time a new shell is being added, every time a new shell is being added, due to which nuclear charge also increase, shielding effect also increase, because filling of inner shell electrons take place. And but if we compare these two, the shielding effect is so pronounced that it causes the expansion of the electron cloud. So that it means the size increase. So in general, when we move from nitrogen to phosphorus to arsenic, we see that there is gradual increase in size. The reason being increase in the number of shell, due to which nuclear charge is also increasing and the shielding effect is also increasing. But shielding effect is so pronounced that it overweighs the nuclear charge, increase in the nuclear charge. So therefore, there is an expansion of the electron cloud. So we see that as we move, the size increase. But if we talk about the increase from arsenic to bismuth, we see that there is an increase, but decrease is very low, very small, but decrease is very small. The reason being because as you move from arsenic to bismuth, there occur filling of D and F orbitals, and they are completely filled. As you can see here, these D are completely filled, followed by the F must be completely filled. So due to which the size actually means or you can say the size, there is no such increase in the size which we see that when we move from arsenic to bismuth. So we see that the increase is not so much, or due to filling of the D and F orbitals. So this is what you are going to explain the atomic radii, and as you have applied the rules for the atomic one, the same thing is applicable for the ionic one also, but there we are talking about the ions. Second is ionization energy. So when we talk of ionization energy, so particularly you know that like whenever we have suppose electron here, I need to remove this electron, I need to supply it with certain energy, and that is ionization energy. So if we compare the ionization energy of 14 and 15 first, we will see that here the configuration is Ns2, Np2, and here it is Np3. So if I try to make a p orbital, so they have 2 electrons, but here they have 3 electrons. So that means the 15 group members, they are half filled, their p orbital is half filled, and we know that half filled orbitals are more stable. So if we compare the ionization energy of 14 and 15, due to their smaller size and due to noble gas half filled stability, they actually have their ionization energy 1 is greater than the ionization energy of the 14th group. Right. So this is how you are going to compare the ionization energy of 14 and 15. How you are going to answer? Write the configuration, and as you can see that here the orbital, each orbital is getting singly filled. So that means it is half filled, and half filled orbitals are they have extra stability, and moreover we know that 15 group members are small in size. So small size, half filled stability is making them more stable. That means the more energy is to required if we need to remove the electron. So if we compare 14 and 15 group, it is going to possess the higher energy. And if we talk of the ionization energy within the group, then as we know, as I told you that as we are moving down, the shell is increasing, number of shell is increasing, due to which nuclear charge is also increasing and shielding effect is also increasing. But as I told you, the effect of shielding effect is more due to filling of the NF orbital, it overweighs actually, due to which the size actually increase, and due to increase in this size, what we see that ionization energy gradually decrease as we move down. Right. So this is how you are going to comment on the ionization energy. Third, we have the electronegativity. As you all know that electronegativity means tendency to attract shared pair of electron more towards itself. So we see that electronegative, the one which like if I ask you that what are the factor on which electronegativity depends. So you know that smaller the size, more is the electronegativity. More is the electronegativity, which means more power to attract the shared pair. So if we compare 14th and 15 groups, so they are smaller in size, 15 ones. So that means they will be somehow more electronegative than the 14 group member. But if we talk of like if we move in the 15 group along the group, we see that size is increasing, therefore obviously electronegativity character must be decreasing, because we know that for a substance to be an electronegative, the factor that is responsible is the small size. So here what we see that the size is big, so nuclear charge is not sufficient, therefore electronegativity is low. So as we move down the group, electronegativity decreases. Now coming on to the metallic character, we see that whether they are metallic or not. So metallic ones are those which have ability to lose electrons, right, and non-metallic ones are those which have a tendency to accept electrons. So we see that here if we compare 14th and 15th group, they are less metallic, they are less metallic. Why? Because they cannot lose electrons so easily, because their ionization energy is high as compared to them because of their small size. Right, so that means 15 group is less metallic. But if we talk of elements within the 15 group, what we see that as we move down, size is increasing, ionization energy is decreasing. That means tendency to lose electron is somewhat increasing. Therefore, we say metallic character increase down the group. So if we talk about the metallic character for the 15 group, we see that nitrogen is typical non-metal, phosphorus is typical non-metal, because they have high ionization energy because of their small size. And we see that arsenic is metalloid, and antimony, bismuth are typical metals because they have big size, they have low ionization energy, and they have actually tendency to lose electron. So this is how you are going to explain the metallic character.